over the last 67 years, I've probably used just about any antenna that's in the handbook. But there are 5 antennas that are the most common. That being a dipole, an inverted V, a vertical, an end-fed half wave, and a multi-element beam or Yagi type of antenna. Those are the most mostly favored ones, because number one, there are some rules when it comes to antennas. I know you don't like rules, but it happens to be a fact. One of them is if you want to know how long it is, a half wave. Anybody know the formula? 468 over F. 468 over F. Yeah, I'm gonna work it down. We don't need to. 468 over F. We'll give it to you in feet and inches.
What's F?
Frequency in megahertz. Okay, so if you wanted to know what it was, 468 divided by, you're cutting it for 40 meters. Let's cut it for 7.1. That's what you would divide into 468. Now, if you want to know what a quarter wave antenna is, all you have to do is take half of that and do the same thing with it. Not hard. Some of the other rules. One of them is when you're cutting any of these antennas or making beam antennas, whatever you're doing, always cut them a little long. It's a lot easier to cut the wire off the ends of it or the top of it or the elements than it is to add material onto an antenna.
Because they don't stretch.
They don't, they don't normally stretch. If you use number 14, you probably don't have a problem with stretching unless you live, in the Antarctic and the wind's blowing 90 miles an hour. It might stretch and break. But that's one of the rules. The other rule is with today's transceivers, I would recommend that all of your antennas be fed with coaxial cable. There are antennas that are open wire feed point and all that, but you're not going to plug that type of an antenna directly into your transceiver of today's transceivers. Today's transceivers want to see 50 ohms on the output. If it has an antenna tuner in it, then you can experiment with different types of antennas. But for simplicity, for the new ham radio operator, all you have to do is plug a piece of 50 ohm coax into your transceiver and you're off and running. Well, that's not true. You can plug it into the end of the transceiver and then start to tune the antenna. I can cut a dipole, as we'll talk a little bit about this. I can cut a dipole for my QTH on 7th Avenue East and put it at 40 feet at each end. And then I could take it over to Bill, WAZ over there, and put it up there and nickel to a donut. We're going to have to tune it again. Why is that?
Different ground soil.
Exactly. Not only ground. Bill's got a building over here. I don't have a building there. I got a building back here, but that's going to affect the antenna differently. So that's the reason I say 468 over F. Cut them long on both sides.
How much longer?
How much longer? I always cut them. Well, if it's for 80 meters, you better leave about 2.5 feet on there. Okay, that doesn't make it hard though. Everybody thinks that tuning an antenna is hard. It's not hard. Okay, so let's say you're gonna cut one for 80 meters. How long is it gonna be? I'll tell you before you do it, 136 feet is halfway, okay, give or take. Okay, for a specific band. What I would do is, because I'll show you a diagram here in a second. What I would do is I'd cut plenty of wire, enough to take that 136 feet. Okay. Cut it. And now I've got what, two pieces. I get approximately 66 feet both sides. I want to try to keep it easy, okay? That's pretty close to what the formula says, okay? So if the formula comes out and tells me that my half-wave dipole is gonna have to be 66 feet on each side, that's the middle, I'm probably gonna cut it 68 feet and get myself a couple of feet to tune. That's really easy. You don't have to cut it. That's what I like, not yet anyway. You can put up a dipole or an inverted V, either one. If you have a dipole up and later on you decide to move the ends down and make it inverted V so you can change the radiation pattern a little bit, you're going to have to retune it because it's going to be different. I can guarantee you. Okay, so getting back to what do you do? What I do makes it easy. Feed line, dipole. This is the feed line, separated in the middle, okay? One side of the coax goes to one side, the other side of the coax goes to the other side. We're gonna call that the ground side. So you got one side of the antenna on the shield of the coax, and you got the center conductor to the other side. I don't care which side you put it on, diagonal. But when you go to tune it, take equal amounts off of both sides. The way you do that is, let's say I want to do, I want to cut 2 feet off of this, okay? We're going to call that 2 feet. I would just take and fold that 2 feet back over itself. Just loop it right back over itself. Tie it with those ties? This is what I do. You know those ties that go on bread, twist ties? That's what I use. I put it back, I tie it down, go check, see how it tunes. Or, and I'm not going to talk a lot about this tonight, I use a vector network analyzer, VNA. They're cheap, you can get them on eBay, all over the place. And they work very well. And you can tune the antenna standing outside and tune it. You don't even have to hook you. I can tune an antenna outside, go in when I get it finished tuned, go in the house, plug it in, and I'm good to go. I don't need to worry about blowing up my transceiver. I don't need to worry about any of that stuff. Do other things happen? Of course they do. But for the vast majority, the easiest way to do it is when the weather's nice, hook your coax, get your antenna where you're going to have it at, plug a VNA on the end, sit, have a beer, barbecue's running, and tune it. Take a look, see where it's at, what the SWR is, and then say, yeah, this thing's tuned at 7.5. Wow, what do I do now? 7.5. I want to bring it down. I just made a huge mistake, didn't I?
Yep.
I cut it too short. Okay.
No, you didn't. You didn't cut it.
You folded it.
Folded it over.
Folded it.
I folded it back.
Yeah.
So now, see, that's the reason for cutting. Thank you, Kelly. That was perfectly timed.
We rehearsed that.
Yeah, so what would I do? I just go out, take my bread ties off. Leave 1 foot, just fold it back 1 foot on both sides, zip tie it again or and go and retune it. It's easy. Yes,
Is there any certain amount of minimum you want to be from your feed point to your VNA
you want to be at the end of the
at
coax.
the end of the coax you put on?
Yeah, you don't want to tune it up there.
Yeah.
I want the coax hooked up.
Yeah.
I want to know what my transceiver is going to look at.
Well, I know,
That's
but
what I want.
You're trying to ballpark it at first out.
Yeah, you ballpark the antenna to start with. Yeah, every antenna you do that.
Well, I'm just,
Yeah.
like me, once I run my coax inside,
Uh-huh.
I can't pull it back out. The way I have it.
Well, then you're gonna have
I run
to-
my coax through and then I solder my end on.
Well, then go in the house and put the
Then do it
DNA
again.
on there.
If I didn't want to, if I wanted to do it while I'm out in the yard, say I have a Yagi laying over on the side pointing to the sky, and I'm trying to tune it, get it close. Do you want to have a 10-foot, 20-foot piece of coax on there?
You don't, if you don't have to, don't tune it on the ground. Okay, because I can tell you right now, as soon as it goes in the air, it's gonna be different.
Yeah,
Yeah, I understand that a lot of guys do that. A lot of guys put the reflector on the ground, point them straight up,
Uh-huh.
but unless you've got nothing around it at all, yes,
Yeah.
go.
Just a comment.
Sure.
If you have an antenna and it's 50 ohms,
Uh-huh.
it doesn't matter how long the coax is, wherever you measure, 10 feet or 50 feet or 500 feet of coax, you'll measure 50 ohms.
Exactly.
Your question about length of coax is if it's not 50 ohms at the antenna where you hook up the coax, and then the impedance you see will vary with length.
Right.
But you'll still see a dip, you'll still see a impedance dip where the antenna is resonant. So you can still tweak the antenna length,
Right.
but if the antenna is really 70 ohms, then how many ohms you measure depends on the length of the coax.
That's the reason you. The easiest way that I can say this is that I want my transceiver seeing 50 ohms.
50 ohms.
That's what I want. I want my transceiver seeing 50 ohms. Is it gonna be exactly 50 ohms? No, it's not. But it'll be close enough, because what's the feed point of a halfway dipole, Bill?
Well,
Around 70 ohms,
70 ohms, but.
70 ohms, give or take. But by the time you you get 65 or 70 feet of coax on there, and you run the VNA on it, you take a look at it, if it's 1.2 to 1, you're good to go. Today's modern transceivers do not like SWRs above 2 to 1. They have 2 to 1 SWR, the majority of the new transceivers. So if you have an SWR higher than 2 to 1, what happens with the transceiver? And I don't even get off on that. So what happens, it starts folding back the power to protect itself. So that's the reason it's important to have an antenna that's tuned. Any other questions about that aspect? One of the other rules is don't get frustrated. Okay, because don't think you're gonna cut it, trim it once and put it up. Okay. Now, we put up a vertical for, what was it? Terry, where are you? Oh, there. We put up a DX commander for him. Looked pretty good on most of the bands. Okay, I put up a DX commander at the house, at my place, with 32 radials on it. And I spent probably 6 hours tuning it. It was up and working. But I was not pleased with the way it was working. Because the DX commander has 6 individual bands on it that are quarter wave verticals. So I had 6 bands. 3 of them were pretty good, actually. 20 was good, 40 was good, and I think 12 meters, 12 meters were pretty good. 15 didn't have a separate element. It used the 40 meter element. You can get away with that. Second harmonic. Okay, so let's continue on. Now you know what the ground rules are. We have a dipole, recap, an inverted V, a vertical, and an end-fed half wave. All of these are good antennas. However, they do perform differently. As an example, this antenna here, we're looking at the side of it. Okay, this way. So the pattern on this antenna is something like this. Okay. In other words, it's radiating off the sides. What does that tell us?
If you're going off the other, off, and you wanna talk to somebody on the ends, it's not gonna work very well.
Exactly. Your main radiation pattern is off the sides. Okay, so now let's take this vertical or this horizontal dipole and put it into an inverted V. The misconception is that they're a omnidirectional antenna. In some respects they are, but I believe, in some respects they are. But what happens is off the ends of this, you get a little load there and a little load there. Can you work guys off the ends of it? Yeah. Yeah, some people do. There's enough power always. Okay. So that antenna in and by itself is probably the easiest antenna to put up and easiest antenna to tune. When they start to get tricky is when you start adding more wire to them. In other words, you have a 5-band dipole. And you can do that.
You're talking about the inverted one or the?
But both of them. You can put another wire on here for 40. This is an 80 meter, remember. You put one on 40, you can put one on 20, you can tie another wire to it for 15, 12, 10, I don't care what band it is.
Yeah, you're talking a fan.
Fan
A fan
dipole?
dipole. But I'm gonna tell you something, when you go to use a fan dipole, you better allot yourself a lot of time to tune it.
And be secure in your religion.
Yes. Because every time you add a wire on there, it's gonna change. The resonance is going to change of the antenna. Do they work? Yeah, they work fine. They work fine. You can do that if you got the room and got the patience. I've had fan dipoles, used them for years. Any other questions about that? Yes.
So if you have multiple wires coming out with the different bands, you're saying that the last one you put on is gonna keep changing one way?
Every time.
Yeah, every time.
Every time.
Yeah, if you have a wire that's resonant on 80. And a wire and you have another one that's resonant on 40. And you combine those two wires into one feed line, it will be neither resonant on 80 or 40.
That's exactly.
They interact, so you have to change the wire lengths to get it back to where.
To get it back to
works on
resonance,
80,
yeah.
40. Both.
They work good though. Just dipoles, yeah.
Couldn't you? Can,
They are worth the time.
can you do an 80, your 80, and just use that as your 80, your 40 and all that?
No. 80 meter dipole is resonant on what band? Half-wave dipole is resonant on what band? 80 meters. Okay,
The next frequency it might work at, kind of.
Yeah.
3 times. But
I'll tell you right now, an 80 meter dipole will not work on 40 meters.
will
Well, that's what work on 80.
Pardon?
Would 40 work on 80?
No. You would have to. Could you make it work on 80? Sure, you could make it work on 80.
But not as well as if you did it right.
Exactly,
Right.
exactly. You could take and put an antenna tuner. I could load a wet noodle if I got an antenna tuner. I can take and load that napkin holder thing. If I got a wide range to match the impedance, you can load a wet noodle. And some antennas are exactly that, wet noodles. And why is that? Because they're using antenna tuners to tune it with. Do they get a good SWR? Yeah, they get a great SWR, 1-to-1. Both my antennas 1-to-1. How high is yours? Yeah, mine's about 1.3 to 1. How's it get out? Yeah, I work with everything I can hear. How do you get out with your antenna?
1-to-1.
You're 1-to-1. I have a hard time working guys. Well,
And you cook pizza on
Yeah.
the tuner.
yeah.
Yeah.
That was gonna be my next point. The antenna tuner, if you're running, like I run a KW, okay? I wanna tell you what, I want my antenna matched. Because if I'm using a tuner with it, it better be really healthy. I'm talking about big inductance, big physical side inductance and physical side capacitance.
Had a fan inside of it.
And a fan going inside it. Yeah, thanks, Bill. And the reason for that is it's matching it. Transmitter says, I'm happy. Transceiver's working fine. Antenna sort of works. And out of that kilowatt, X number of watts is being dissipated in the tuner. So I hear guys say, we're just, I work that, I work this. What's the SWR? Can you work stations with a high SWR? Hell yeah. Not near as well as you can work with an antenna that's actually radiating. Yeah.
So on your fan dipole, is there a band that you'd want to start with when you start to tune it?
If it were me, I would cut them all halfway and a little longer
Yeah.
and get them all up there first
Um,
and then start tuning.
right. But
Is that what
I
you
didn't
did?
know if you would want to like start at 40 or 80.
Boy, the top wire is going to be the highest band, or the highest band you're
Right.
using.
Right.
Your
So I
80
didn't know
meter.
if there was a theory behind building,
No, there's no theory.
build a fan dipole.
No.
Could you start with 80 or 40 and work your way down and then try and find your?
I would start out 80 meters and then and get them going first. Okay, and then add
Did you
40
say everything?
and retrim, and then add 20 and then retrim,
Yeah.
and
Every
15 and
reaction
retrim.
reaction, so I didn't know.
Absolutely,
Yeah.
absolutely.
So,
I
Jim,
started on highest band, yeah.
so if you're building a fan dipole.
Yeah.
That's something that I've been interested in.
All right.
You wanna, and you're gonna tune it, I mean, it would be very inconvenient for me to have to raise that thing up my flagpole and bring it down.
Don't put one up then, Bob.
Well, I mean, okay, so you gotta raise that thing up.
You better plan on tuning it, yeah.
You wanna be as close to where you plan on operating it, yeah.
Yeah, cut the wire, add a little bit as you go up in band, and as you go down, as you go up in frequency, down in band number,
Mhm.
up in frequency, okay? Let's say you go to 10 meters and you wanna make a 10-meter dipole. You don't have to put an extra 2 feet on there, okay? Because as you go up, the antennas are shorter, consequently, it doesn't have to have as much extra on it to tune it.
That's the nice thing about an inverted V is once you put it up, what you're doing is trimming the ends, which you
Right.
go down lower.
Down low.
But if you're not gonna tune it, you don't wanna tune it.
No, I was,
I don't put any inverted V up or any dipole up that hasn't got ropes on the end, so I can drop it down and tune it.
Yeah.
You don't wanna go up there and say, okay, plant that baby, put 40 feet of pipe up there, guy it all off, go in the shack. Or stand out there with your VNA and say, oh, damn, the SWR is 1.9 to 1. Undo see what I'm saying? Anything that any antenna that you put up other than beams and Yankees and that kind of stuff,
and then how far away does each element have to be from the?
you have to find that out for yourself, Bob. There's no formula. Kelly runs is usually.
Yeah, I run the 5-band, 10, 15, 20, 40, and 80.
Okay.
On 160, actually, it's a 6-band. And they're not very far apart. They just have spacers on them, but I've got the 80, the 160 and the 80 are on one set of leg. And then the 40 and the 20 and the 15 are on another set of legs, and then there's a separate set of legs for the 10. But they're just separated by short spacers like that. So it's not really easy. So the longer leg is holding up the rest of them.
I've seen guys take and put dipoles up, support not inverted V's, dipoles. Dipole up, fall, come down with the 40, attach it, come down with the 20 or the 30 meter if you're a 30 meter fan. And so forth and so on. No reason why you can't put them, you could put one up for every band if you wanted to, if you got the room. You could have a,
Patience to tune it.
patience to Joe.
They're gonna interact with, you have the wires close together
Right.
or space them out.
Yeah,
They're still gonna
they're
interact.
gonna interact.
So
Some more than other. I would think I would think that the closer they're spaced, they're probably gonna interact a little bit more. Closer they are to each other. I mean, it just sort of.
If they are closely spaced, like the antenna that I got, it is easier to put up, it's easier to handle, and it's more handy to have in your yard.
DX engineering isn't.
No, it's Alpha Delta.
Alpha Delta.
Yeah.
DX engineering.
Well, yeah, that's true. So, but, and I have had fan dipoles up where I'd run two legs this way, and then I'd run the other one for 40 and run those this way, and then the other one for 20 this way. And didn't have as good a luck as that with those as I do with my Alpha Delta, and they're just spaced apart. The best SWR I had on my 160 meter antenna when I had it up was 1.8 to 1. That was at the resonance spot on my fan dipole for 160, 80, and 40. And when I put the Alpha Delta up, I mean, I can get right down to 1.2 to 1 at the resonance spot. So, and they're just short spacers.
I was just gonna compliment, because this has happened to me more than once, I've quite a few dipoles. When I've used that formula, I had found that it's actually cuts it a little long in the locations that it fits there. And I've actually had to shorten it more than what the formula gave you to
Good idea.
make it resonant,
Yeah,
you know,
468F is not magic.
yeah.
That's the starting spot.
Free
Right.
space.
Yeah, and yeah, thank you. I was just sort of mentioning that.
Yeah.
That is in free space.
In fact, they tell you to put in a 5% difference, I think, when you're
Yeah.
doing it like we do
Pick
it.
a number, you can put whatever,
Right.
just don't cut it short.
Right.
And don't do 468 divided by the frequency you're operating on and cut it right exactly that frequency.
And leave a little wrap through the insulator and wrap it around
Exactly.
too. So-
Okay, let's talk about verticals. We know what that thing does. We talked a lot about that. More than I had planned on, but that's okay. You guys got good questions. I got good answers. Verticals. Quarter wave verticals. There can be other lengths too, but I'm not gonna get into that tonight. Because that's a whole other kind of thing. And you can make a single piece of metal operate on many bands, but it doesn't do it for free. Okay, if you're gonna put up a vertical, put up a quarter wave vertical. Put lots of radials on it. If you can't. Quarter wave long. On 40 meters, Bill, 40 meters, how long would that be? About 33 feet?
Yeah, 36 feet or so.
So ideally, what I would do for 40 meters is make this vertical a quarter wavelength long. And again, probably the top of it, I'm gonna make it out of telescoping tubing so I can adjust the length. You want to get it all going first. So you got your quarter wave vertical. Now, will it radiate by itself? Yeah, sure it will. It's a quarter wave vertical.
Is that what we have on our DX?
No. Well, yeah, but I'll talk about that in a second. Will it radiate without radials? Yeah, sure it will. Will it radiate as good as it would if it had radials on it? Absolutely not. So, what do? Now, this is a case where you don't need to get real excited about cutting them too long. Cut them quarter wavelength. You'll be okay. Tack on 5% if you want. On the radials, when I'm talking about the radials. Out around the bottom, on the ground, laying on the ground. I don't care what you do with them. You can lay them on the ground, you can bury them. The soil around here isn't all that hot anyway, so it doesn't really make any difference. I've done tested it. You can lay them on top of the ground. You can bury them 2 inches under if you got lawn. Put them up in the fall. Okay, lay it in the grass, and by the time you come back out there next May, you want to be able to find them. All right, so
Is under gravel, okay?
You can put them on the gravel, you can put, yeah. As long as you're not putting it under like a metal sheet or something. So ideally, I would like to see. There's all kinds of theory about this. You can put like as many as you can down. Let me put it that way. Put as many radials on that hammer as you can. I've got 32 on mine, but they're short radials. Okay, that's the nice thing about doing that. You could put 4 quarter wave wires out underneath it, or you could put 32. They're about 3 meters, about 10 feet underneath it to make it perform. And let the transceiver see 50 ohms.
You can only do that if you put them underground or on the
Yes.
floor, right?
Yeah.
Yeah, you can't do it elevated.
So you don't elevate verticals. They don't work elevated unless you put radials out on them, above ground radials.
So do the radials add to the ground side or to the length of the antenna?
What they do is contribute to the pattern of the antenna more than anything else, in concert with getting it down to 50 ohms. What you want is the feed point. So you tune the antenna, you put your radials out quarter wavelength long. Here's what's happening. Why do guys use verticals? Anybody got any idea? They're noisy, one. That's not myth. Vertical antennas are normally noisy, particularly if it's man-made noise. Power lines, yada, yada, yada. Okay. They are a little bit noisy, but they've got a huge advantage over horizontal antenna, unless you can get that horizontal antenna at least a halfway above the ground.
Takeoff angle?
Yes, here's what happens. The vertical antenna, really good antenna. I'll put up with S1 or S2 noise. Okay, if I can work that guy in Europe. I'm 40. So what you have is that's the curvature of the earth. You have a radiation pattern that is low to the horizon. That's important because it puts where the antenna hits whatever layer we're going to hit, whether it be F2 or ionosphere, it doesn't make a difference. Whatever layer it gets to, okay, is going to be down low, so it gets to look at it. So your signal goes like this, as opposed to having a high angle of radiation and your signal going up like this and come down like that. That's the whole idea of a vertical, is the low angle of radiation, plus the simplicity. As I said, the downside, they all got downsides, okay? The downside is that it's a little noisy, but I'll put up with the noise, okay? I mean, I can get on 40 meters at night and work in Europe, no problem. So, something to think about. Simple antenna too. All right. Any questions about verticals?
So the radials are pulling your takeoff angle down towards the earth. It wants to pull your
That's what happens.
energy leaving your antenna.
So
back
the
down.
pattern of the radials, does that matter, or can I just like?
Evenly
spread them
spaced
out?
all the way around.
Okay.
Evenly spaced
You
all
don't
the way
have
around.
radial.
Or if you're planning on working, you want to just work in Europe, okay? You can take and lay the radials out to favor Europe.
Why don't you put one up in the middle of one of your big buildings? You got metal roof, don't you?
Yeah.
Put it right up in the middle of
You
that
can put a
metal-
vertical on top of that. Use the roof as the
Yeah.
radials.
Yeah.
Oh, yeah, that'd be the best.
Okay, any other questions?
Yeah, I noticed, I had a butter knife. At my
I have one.
house, I had it up on the roof. great place to put it. And I put the radios out on the roof. And I noticed that the more radios put out, SWR kept coming down. Until you reach a point of diminishing returns.
Of course, sure.
Something.
I had a butternut, 5 BTV, 6 BTV, anyway. I wasn't particularly fond of it, but it did work well. It did work well,
What I've
yes,
got now is it's
For vertical on a 40, 50 foot mast, how do you get it and the radios together?
if you put the vertical up on a mast. Unless you hang the radials off like this, from that 50-foot mast.
Okay.
That's the only-
You don't
You
put it
can
down.
still do it, yeah, you can put a vertical.
Well, you keep that, those, but I mean, I don't know what the radios on the ground.
No, you have to have them at the feed
That's
point
what
of
I
the
thought.
antenna.
Okay.
You have to have them at the feed point of the antenna.
So when you do that, and the radios are up off the ground, that's generally called a counterpoise.
Right,
Right, and it's pretty efficient,
yeah, it is.
because the current tends to flow in the wires, not in the ground below it.
Yeah.
When you have, if you don't have radios, for example, all the current in your antenna is also flowing in the ground, and you're gonna be heating up the ground, so that's the purpose of radios. is
Not
that
to
you
kill
don't
the grass,
heat up the ground.
It won't kill the grass.
Because you close in the top of the wire, it doesn't lose much.
The other advantage, and I'll get,
But then all over the place with that much hanging up there.
Yeah.
No support.
That's only if you live in the windy area.
if you have a vertical, if you have a vertical and you put 4 radials above ground. All right, 4 radials above ground. That would be like laying 8 radials to fortify Bill's point. If you had 8 radials on the ground. So if you put 4 up high above the ground, or 8 on the ground, you'll have about the same amount of performance, give or take,
Yeah,
a
but I
dB or
can
so.
see that.
Okay, yes.
So with the counterpoise,
Uh-huh.
the angle of the counterpoise matter, because when I built a little vertical antenna, I was getting pretty bad SWR, so I bent them to line a 45-degree angle. Is there a specific one, or is it kind of?
Normally, if I put up a vertical and it's gonna have above ground radios, I usually try to get the radios at 45 degrees to the antenna. Give or take. Yeah. Okay, verticals, okay. Let's talk about my favorite. End-fed half-waves. End-fed half-waves. So you put up a piece of wire, a half wave above the ground, and end feed it. How do you do that?
Just a vertical leg down.
Well, there's a couple ways to do it.
You got a balun too.
So you got this pole, another pole. They're 135 feet apart. Then you got this long wire going out here and it's terminated there. Not terminated. That would be another antenna. Support. Got an insulator out there at the end like you should have on the ends of an antenna. And now you have to feed it. Well, the impedance of that antenna can vary from anywhere between 500 ohms, which ain't anywhere close to 50 ohms, and 1800 ohms. So we have to transform the feed point of that antenna to something close to 50 ohms. So we would use a balun to feed that with. Or you could get gutsy like I did and just feed it with some coax and hook it up to a big old tuner that'll take 2 kW and tune it. Did it work? Yeah, it did work, but not near as well as it should have. So baluns are, I'm not going to go into baluns and the theory behind baluns. Let me just put it this way. A balun is a impedance transformation device. The typical balance are 49-1 for the end fed, half-wave end fed. You can build the balance. I've seen guys build them. I build them all the time. Couple of rules when you do build them. Don't use well, you can if you're gonna run 100 watts, ain't no big deal. You could do it with number 14 insulated wire. You buy a 500-foot roll, it loads for about $70 now. It used to be about $49.95. And now it's about $70. So you can use that wire to wind one. Then you have to have some FT243 magnetic cores or toroids. And there's a whole raft of information on head fed halfways. In fact, it's got a Facebook page. Pretty interesting at times to hear what people think how they work. But it's a good antenna. Kent uses one on 80.
Works into Europe,
Yeah.
long path, I get long path in the mornings, into Eastern and Western Europe.
On 80 on 80
meters.
on 80 meters. But you got to remember, Kent is running some serious goo. So
Got some power in it, the transformer, I got it, it'll handle 3 kWs.
yeah. So
What do you call it when you feed it at the ground on end fed?
well, that's an
When
inverted
you
L.
just run it at an
That's
angle,
an inverted L.
A sloper.
like a sloper fed at the ground. Is that end fed?
It's still end fed.
Yeah.
Yeah, it could be an inverted L. Same theory behind it. Okay.
I didn't know if you're matching
You could have
closer.
this wire here. Let's have an insulator right there. You could have this wire, all the way down to here. Still gotta match it.
Right, I didn't know if it'd be easier to match it there or
Either one of
don't
them.
matter.
Mine's at the lower level, right,
This
my
is-
level right here, wire goes up and over.
That's an inverted L. He's running an inverted
Yeah.
L. Yeah, how far up does it go?
50 or 60 feet, high as I could get it with the slingshot.
Okay, so that's, yeah, that's
70.
It's an inverted L. He's running an inverted L. Great antenna.
That's right.
Okay, any questions about that? Anything, any questions? I'll close here with a couple of comments. Beam antennas, very quickly. I don't want to get into the theory behind them. Once you understand the theory of these antennas, you'll understand the theory of a beam or a Yagi antenna. Okay. Beams work well, they're expensive. Okay. I got a 7.6 meter Yagi up and it was close to $700. Same thing with my 2 meter Yagi, but they're both long antennas. They're both got 40-foot booms on. But yeah, if you're gonna get a beam antenna, there's nothing for free, let me tell you. And the prices of antennas have gone up just crazy. Okay, here's the thing you need to watch very closely when somebody's selling you a Yagi antenna, any antenna that says it is 15, no, yeah. It is 12.4 dBi gain. You start to think, boy, that's good, 14 dBi. That is in free space. And you're not going to be using the antenna in free space up there with the space station. So what you need to do is subtract 2.4 dB from that. That'll give you real world gain. You put it on an antenna.
Compared to a dipole.
Compared to a dipole. All antennas. Now, take that back, not all antennas. Our kind of antennas are, when they talk about gain, are based, as Bill said, they're based against a dipole.
They call it DBD.
Yeah.
DBI is a BS number.
If it says it's got 14,
Yeah.
if it says it has 12.4 dBd, that's a player. If it says it has 14 dBi and the guy next has another one in the same ad, same magazine, it says his is 14 or 12 dBd, take the one that says dBd. If you take the one that says dBi, subtract 2.4 dB from it, that'll tell you what the real world gain, what the DVD gain is. Any other questions?
How do you tune that stuff? You have to clip the various radios?
No, yeah, what, a beam, a Yagi antenna,
Yeah.
you have to tune it by adjusting the lengths of the antenna, lengths of the element. There are a lot of beam antennas that, you know, you can build in your backyard. Okay, cubical quads, delta loops. I mean, the list goes on and on. And I played with delta loops, I played with quads, verticals, dipoles, hexes. Yeah, just a lot of different antennas. If you're just getting started, just learning, or just learning theory, stick with the easy ones. Okay, that's what I would recommend.
I've got an in-fed halfway, and when the last breeze came through it, it blew the wire over into the trees. I can't see much difference.
Probably not. A lot of that has to do with what part of the wire. A lot of that, you see, that's a good question.
Yeah.
That's a statement, because depending on what part of the wire is in the trees. Okay, evidently you got a part of the wire into the trees that doesn't have a lot of RF in it, and that's okay. It's still there. The antenna's still working. It's just that at that point where you got it in the trees, there's not much RF there. So there, consequently, it wouldn't, wouldn't affect the performance of it. All right, guys, it's 10 after. Just
Thanks, Jim.
You're welcome.
Thank you.